You know, for thousands of years, we've been using certain spices in our kitchens and in traditional medicine. But what if I told you one of those unassuming spices is now getting some serious attention in modern labs for its potential to wage a secret war on cancer? Well, let's dive into the incredible science behind this ancient remedy.
So take a look at this. This is the Nigella sativa plant. It's a beautiful flower for sure, but the real power, well, that's hidden in its tiny black seeds. You might know them as black cumin. And inside these seeds, scientists have found a compound that's showing some absolutely incredible promise in early research. Right, so black cumin has been used across different cultures for all sorts of ailments for centuries. But what's really fascinating is how modern science is now circling back and actually starting to validate some of that ancient wisdom, putting this spice under the microscope to see what's happening at a cellular level.
All right, so what is the secret ingredient here? What's actually doing the heavy lifting? Well, meet the commander-in-chief of black cumin's biological army, a powerful little compound called thymoquinone. This is the main active substance that scientists believe is responsible for all these effects we're seeing.
Thymoquinone, or TQ for short, is really where all the action is. Lab studies have shown it has some potent anti-inflammatory properties, but the real knockout punch, at least for this discussion, seems to be its chemotherapeutic abilities. This is the key player, the one compound scientists are zeroing in on in the fight against cancer cells.
Now here's where it gets really interesting. It's all about the strategy. See, unlike a lot of conventional drugs that might just target one specific weakness in a cancer cell, TQ is different. It launches a multi-front attack. It doesn't just do one thing, it wages war on malignant cells from a whole bunch of angles, all at the same time.
Let me break down that battle plan for you. First, TQ halts reinforcements. It literally stops cancer cells from proliferating, making more copies of themselves. Second, it hits the self-destruct button inside those cells, a process called apoptosis. Third, it blocks the invasion, helping to stop the cancer from spreading to new territory. And finally, it cuts the supply lines by choking off angiogenesis. That's the process tumors use to grow new blood vessels to feed themselves. It's a truly coordinated assault.
So you might be wondering, how on earth does one little compound do all of that? To get it, we have to zoom way in, down to the molecular level. The best way to think about it is sabotage. TQ systematically cuts the communication lines that cancer cells absolutely depend on to grow, survive, and spread.
And here are just some of those communication lines it targets. Now look, don't let these complex names scare you off. NF-kappa B, PI3K/ACT, MAPK. What's really important is what they do. These pathways are basically the command and control systems for cancer cells. By hitting so many of them at once, TQ basically throws the enemy's entire operation into chaos.
So what the heck is a signaling pathway anyway? It's really just the way cells talk to each other and get instructions. In cancer, these communication lines get hijacked to send out bad orders, like grow like crazy and invade new tissues. TQ's whole mission is to get in there, intercept those messages, and just cut the lines.
Okay, so with a strategy that comprehensive, you would expect to see some pretty impressive results in the lab, right? Well, that is exactly what the preclinical data is showing us. Let's take a look at the battlefield report from these early studies, which are done in vitro, that's in a lab dish, and in vivo, which means in animal models.
And wow, the range of effectiveness they're seeing in these lab studies is pretty remarkable. TQ has shown promise against a really broad spectrum of malignancies. We're talking about lab models of some of the most common and toughest cancers out there: breast, colon, pancreatic, lung, prostate, even blood cancers like leukemia. This huge range of activity really drives home the power of that multi-front attack we were just talking about. So this all sounds incredibly promising, which of course leads us to the big question: how can we actually use this? And maybe more importantly, what's the catch? And believe me, this is where we have to take a big, important dose of reality.
Now, in the existing studies, they've looked at a couple of potential ways to administer it, either as the whole seeds or as an encapsulated oil with different dosages. But honestly, talking about how to take it brings us to the single most critical point of this entire explainer.
And here it is. I'm going to read this to you directly from the source material because it is just that important. Unfortunately, there are no published clinical studies that have investigated the effects of Nigella sativa in patients with cancer. All of this powerful, exciting evidence we've just gone over, it all comes from preclinical studies, in petri dishes, in animal models. It has not been proven in human cancer patients.
So let's just be absolutely crystal clear here. The science is exciting, the mechanisms are fascinating, and the potential could be enormous.
This research needs to continue, 100%. But as of right now, this is not a proven treatment or a cure for cancer in humans. It's a very, very promising lead, but it is not a foregone conclusion.
And this whole story leaves us with a really powerful question to think about. The story of thymoquinone shows us a compound from nature that doesn't just fight cancer cells, it seems to outsmart them on multiple fronts. So it really makes you wonder, could this kind of multi-targeted strategy, inspired by a simple spice, be a blueprint for the future of cancer therapy? The research is ongoing, and you can bet we'll be watching.